Okay, that tells you what we're going to talk about. It also tells you what we did talk about. We've been doing it for about a year, and in usual format, especially for people who are here for the first time. The usual format on starting the video. The usual format is we talk about something, we talk about the interesting new things, and the emphasis of what we talk about is usually on practical aspect. In other words, we're not just interested in hearsay. We want to try it, or we want to understand it. And therefore, I have a theory portion, which is still about deep inside, how does it work, and then the practice. So I'm giving you the link here on chat. Okay, from Dallas for the first time, awesome. And there is no great system in what I'm doing. I talk about what happened to me that last week, what were the most interesting practical news that I saw, and I will explain why. And then something of my projects. And once in a while, I give you guys a chance to run a lab, and we do what's the latest in the education. I showed people a long plan of what you can learn, by the way. That is right here. So if you look at this Advances in AI web seminar, what we were doing, and no, that's not trainer. It's just Mark. Okay. It all started with training, yes. But that's our folder. So if you want to see all the documents that I collected, they would be in this folder. And if you want to see what's the learning plan, because people often ask about this, that would be right here. I kept it secret, but after a while, people kept asking about that. So that's, if you want to learn about AI, there, of course, you know, it's a popular area, very popular. I cannot sleep at night because of it. And it is also fast changing. What's important is that new courses come in. Look, 24. And that's all from different sources. Mostly it's under AIM. He does an amazing amount of courses, and everything here is free. So even if you want to pay because you believe that when you pay you get better quality, there's nothing you can do here. Okay, that is it. But what we're going to talk about today is this: running LLM on a phone, meaning can I run it on just a phone, no connection to the internet? Because of course you can run it on the phone, and there are apps, and there are also browsers in the phone. But no, we want to run on the phone hardware. So maybe I should put here on the phone hardware. That is very clear. Now, one of my friends brought it up. These are the links. We're going to go through that. And the reason it was interesting to me is because with yet another friend, I'm working on something that would be useful to a certain group of people, but only if you can talk naturally. So anybody can now talk to ChatGPT in the sense of typing, and you can build it. It's not hard. I just gave you the link, this one. That's where you learn how to do it. It's called RAG, and RAG is just, every time I mention the term, I say how much I don't like it. But it's a term that exists and it means specific things. It means this: very simple architecture on making ChatGPT or another language model. But ChatGPT parenthetically is better than all of the models. So anytime you want that to run on your documents, many people don't want to give their documents. They're bound by some regulations like CGIS and HIPAA. And it's a lot of documents usually. So anytime you want to do it, you use this architecture. You put your documents properly curated and cut up into a syntactic search engine. You can put it this way, or a vector database. There are many terms of art, but it searches your documents by meaning and not by keywords. That's a big thing. It was invented in 2013, and now it is a standard thing, and it means a lot. But nevertheless, even though you can do the search, the real revolution, of course, is the ChatGPT or the LLM, if you don't want to sound like you only like ChatGPT. Okay, and now we're talking about everybody's using them. So using this RAG architecture, retrieval augmented architecture, which means you stick it all into the search engine, and first you look for pieces of information that are relevant to your question. You get a list back. All of that is easy in Python. With that list, you then go to ChatGPT. In particular, I use a library called LangChain, and with that, you get the answer. Now, it's your choice how more complex you want to make it. You can then filter the answer. You can have multiple questions you ask of ChatGPT, like you can first ask, okay, I have a question. What is it about? Is it about physics or about my favorite ice cream? And keywords don't help, so you just ask ChatGPT, what is it about? And it tells you. Now I have a bit more people come here, so I allow all of them to talk. Please speak up and interrupt and do anything you want. That's the purpose. So we were talking about running LLM on a phone, and we were saying the standard architecture is well known and anyone can do it. And you can even do a multiple question ask silently. So you will ask ChatGPT, what kind of question is that? And if that's one way, then I will continue conversation in one way. But you can also filter what it gives you back. So you have full control of that, but all of that takes time. And there are some applications like robotics or chat applications that simply will not be accepted by the people if it's too slow. We should be able to interrupt. We should be able to talk real quick. So here is the story. There are three parts to this story, 1, 2, and 3 right here. And I go first to this. And that comes from, what is it? Financial Times. Or maybe some other, Ars Technica. Okay, so a few words about this first article, because that's where it came to everybody's attention, even though that was not the original article. Now those fonts don't mean anything, it's just a picture. And what the key word is Apple's latest research offers the clearest signal yet that the iPhone maker want to catch up with the silicon rivals in generative artificial intelligence. What he wants to say is that we didn't see a model from Apple, right? We didn't. We saw a model from ChatGPT, we saw a model from Facebook, and right now we're not going into evaluate, do like them or no. But now he talks about that here is what Apple plans to do. And again, the reason it's interesting, if you want to build some application. If you don't, well, you're just curious. That's the only reason you could care, because right now it's not out. Similarly, it will be out soon. And seemingly, Apple wants the world to know that it will be out soon. But he says that the paper was published on December 12. Well, it's not too long time ago, but people didn't notice it. But then 2 weeks later, or 3 weeks later, Hugging Face, by themselves or with the authors of that paper, published it again, highlighted it here. And then he goes and gives us a good background. So for me, for example, who is kind of out of this world, I had to look every one of these keywords on Google or ChatGPT. But he talks about that in the end, Apple plans to run the model straight on the phone, no contact with the outside world. And so that's interesting to some people who are into privacy, but 50 times faster. Well, that is really catching the attention of everybody. That's why everybody is talking about that. Then he talks about that there are two problems. First of all, Siri is our Apple's AI, and it's not great compared to what ChatGPT does. Microsoft and Google are concentrating on web delivery. And in general, people are not buying as many phones as they used to, which of course is a problem for you if you make those billions of dollars with the phones. So to you, and he quotes 5%, 5% dip in how many phones people buy. Well, that's very, very important to them. So this new way of making your phones extremely smart, not just in addition to the fact that it can run any app, but 50 times faster than the others, that they will hope will revive the market and probably even make it bigger. He talks about a model called Falcon 7B. I looked up, first of all, there is a confusion. There is a phone that costs $45 million. That's a special phone. If you're into those things and you want to show off, that's also a phone, but don't confuse it. It's a model. The model, you can find it. So yes, there is a model that runs on the phone, and soon, I think, it will be out, and they say that Apple didn't tell them when. All right, then what we do is we go to the link that they point to, highlighted here. Okay, so it turns out that beyond this little article in Ars Technica, there is a article in Hugging Face. Well, Hugging Face is just pointing us to the real stuff, but here they give you a little abstract, and they talk about that, yes, you can run LLMs on a small phone. Now they introduce a couple more terms. It turns out that our phones have a regular memory, direct random access memory, DRAM, and they also have an additional flash memory. DRAM is much faster. That's what will give you the speed, but it's not holding each individual model. The models today are bigger than all the DRAM you can have. So again, I didn't know, is that true? Do they have them or no? And I went to ChatGPT and I asked, and I think I'll better just show here. Phone, do they really have DRAM and flash? Yes, they do. And careful, ChatGPT doesn't want to offend anyone, but he talks about the high-end phones, because you would expect that people would be expected to buy a more powerful phone to use AI. But the amount of DRAM is between 8 to 16 gigabytes. It's not bad, but Flash has much, much more, and it can have up to 256, 512, and 1 terabyte. So now we need to just look up in the article and find out which numbers are we really looking at. Now, a little bit of the chat. Let's see who says what. Okay, so Kiran immediately tells us something very interesting. And he said this approach Apple is taking with MLX, a replacement for PyTorch. Now, for those who don't know, MLX is a library and PyTorch is another library. And where the current models like Llama and other can be compiled into silicon is a good approach. They're slowly creating the ecosystem with Macs, phones that can do an on-edge LLM. And DRAM speed makes a difference. Thank you, Kiran. Now, that kind of shows us that, yes, we are talking about the right thing and going in the right direction. But what I want to do is look at the article and find out how serious is that. People write articles, and that makes them famous. And why did Apple publish it? I am not privy to that much information, but I want to see how solid is that technology. So we already saw the numbers of DRAM and flash, and they talk about that with the result that using them together, they achieve a either 4, 5, or 25% increase in speed, not percent, increase in speed. I said 50, that's just dreaming. Hallucination is, ChatGPT is known for that. Well, now we need the real article. The real article is found here. If you say view PDF, I already downloaded it, so I'll just switch to that. That's the real thing. Okay, and we only need to look in the beginning and the first few phrases. To my view, it's a very well-written article. So they talk about that they use a combination approach. They use DRAM, that is found in the phone. They use flash, and they basically load the complete model as flash in flash. That fits within this flash memory informed framework. That's what they do. So they have the complete model. Which model? It seems like that will be open. They talk about LLM. That's up to them. I'm not designing, so I'm not very much into every detail, but the basic understanding. So yes, they have a slow but big memory, and they have fast but small memory, and that's flash memory and DRAM. But it requires some smarts. It's not like that, and the first picture shows you that it is not just simple-minded approach, which they call naive approach. So naive approach is just load them and see what happens. But the approach is shown right here, ours, that achieves the 25 or 50 times speed up. And now they tell us about how they do it. Well, it's not that hard to understand. First of all, they are doing what they call windowing. That is just blocking. In other words, when you exchange data between flash memory and DRAM, you optimize the size of the block. Because every time you go from one memory to another, that means you're opening a connection, maybe a socket or any other connection. But this opening is usually slow. So they optimize it by sending a pretty big chunk of memory from the flash to DRAM. But that's only the beginning. The next step is how do you package the data? That's talked about right here. It's called row column bundling. A row column, again, that is a well-known idea. It is found in big data. And what they are saying is this. If you just look at any database, it's very natural to say that each row, each entry in this database is what you need to read. It's a record. It's one thing that you get at a time. But that's optimized for logic and for understanding, not optimized for speed. So for speed, people notice that very often they look at the database by columns. For example, if I need to count how many rows I have, it is select star from whatever. By default, the database will bring back the complete row, whereas I only need one row, one column. For example, if I want to find the max of something, well, only bring me one. And that will be a speed up. So how do you combine those two things? You create what is called row column bundling. In each individual block, you organize the data by rows. So you have all the advantage of row. But between the blocks, you go by column. I messed up it a little bit. In each individual block, you do it by column, but between different blocks, you do it by row. That's the second idea. But that's not the only idea. Now they notice quite a few things about the model itself. The model is not using all the data all the time. So it doesn't really need all the data. And it turns out that some models are sparse. They talk about it right here, our integration of sparsity awareness. So if I have a certain part of my neural network that I'm not using, then I don't need it. They only bring in those pieces that they are using, and it turns out that those pieces they are using are not all that voluminous. So in the whole neural network, only some pieces are really deserving to be brought into fast memory. That's the third improvement. So they integrate the sparsity, and they also mention cleverness somewhere. Cleverness, not in the sense of general being smart, but in the sense that they look at how they are going to use the hardware and the software, and they use them together so that they achieve the maximum efficiency for the cases of limited memory. That is my basic understanding. So I think it is real. I think it's coming soon. And my case, well, I'm building right now a little application, and my goal is chat application so that the person can just talk to his phone to get smart advice, and then reg architecture. So it's all well-known architectures, but I have an eye into the future, and if I know that the phones that can do it are coming, then that may change the way I program. So right now I'm in the POC stage, and a few more words only here is that they talk about how great those models are and what they can do, and then they talk about that the standard approach is to load the entire model into memory, and now come the real numbers. They say a 7 billion parameter model, and that's not the largest and not the most powerful. It requires 14 gigabytes of memory. And we remember, these are just the kinds of numbers that we looked at. By the way, in the previous discussion last week, I noticed that Andrew Karpathy, yes, he is a well-known authority on that. He mentions that there is a beautiful straight line dependency between the size of the model and the smartness. So you can invest another $500 million into a bigger model and get smarter results. And if so, then 7 billion is a good number. Not that it is enough, but that is some good way to estimate the size of the model. And yes, 7 billion, but even up to a trillion, that's what people do today, to make it very practical and to estimate, will my phone be able to do it or not? But 7 billion is enough. And that would require 14 gigabytes of RAM, exactly the size of my DRAM. So I'm dangerously close. And even if I do all possible compression, have precision floating point format, still I'm out of my memory. That's it. Then he talks about a specific model that is very smart about concentrating its thinking in specific areas. And that opens a way of combining flash memory and bringing only the important part of the model into DRAM, while the rest remains in flash memory. Now I understand what they meant from the very beginning, that they have to be smart about this architecture. And in this picture, they talk about DRAM and CPU and GPU. That attracted my attention because I didn't realize that GPUs are even found in the phones. Yes, they are. It's just that nobody cared up until now. But yay, they have DRAM, CPU, GPU, and so on. Well, that's enough because you can look it up. The links are all here, and you can do more. So what I will do is stop talking, stop sharing, and give you a chance to talk or ask something. So I'm giving a chance to talk to everybody else here. Okay. By the way, that speed, before I stop talking, that speed is also important, let's say, in robotics, because if the robot is too slow, well, it's not useful. That's an interesting fact. Okay, stop share. And not necessarily mute myself, but stop talking. Okay, now the next thing I want to share and actually offer something to you is this. Sharing the screen again. So I have an open source application. It is for lawyers and it allows them to do what's called e-discovery. But recently, I included AI into that and packaged it so that I can give it out to people. So it is delivered as a virtual machine. Right here is the virtual machine. I'm opening that. That's the virtual machine that I will give to the people. And I will give them with the instructions. And even though it's all programmed inside, but it responds to the outside. As you can see, I'm in the browser looking at the interface offered by this virtual machine. And I'm showing you all of the inside and outside because you guys are technical and that's what comes to those discussions. So right now, what it can do is search. Let's say, is never even mentioned. No. How about John? No. Melissa? Yes. So there was one Melissa here and we're right here. Well, that is a standard search application. No big deal about that. And I can search for star. And if I search for star, then all the documents come up. Well, again, no big deal. You can find such search applications. Where the AI comes in is where it looks at all the documents. Now, that's bigger than your regular ChatGPT applications because ChatGPT will not take 100,000 of documents and usually have more. You usually have millions. So you must have a reg architecture in addition to that. That's found right here. So now it's the same data, but you can either search or do the ChatGPT. So let's say who are the people involved mentioned there. Let's see. Now I was talking about very fast answer. These answers are reasonably fast. Okay, they're all here, right? So if I want to go into detail, then ChatGPT usually gives me a very broad answer, and then you cannot control it. It just does what it wants to do. So if I want to look at, oh, it mentions Nancy Pelosi, really? Well, it's just because of my document that I added to the set. So I'm saying where. I could ask ChatGPT, but I really want to see the documents. Okay, so show me Nancy Pelosi. There she is, and then the talk, what she did. That is the document that mentioned her. All right, so now I can go and ask what it means do. So that's what she did. And initially I put it in because I wanted to show summarization capability. But more questions come up, for example, is there PII in these documents? In this document, it understands, I mean, all documents. No, in these documents, it understood that I meant all the documents. Well, what I find is that, yes, it is oriented towards lawyers primarily, but technically, on the other side, it's generic architecture. Let me show you that generic architecture. That virtual machine, that version that I only give to developers, my own developers, because it has all of the code, has a VNC entry. And the VNC entry as the password. And then I have everything running. That's how it works. So if I want to manipulate or do something, as you see, that's the question that I just asked. It's logged here. And there are other things. For example, let me open the browser. Now I am within the virtual machine, and I can look at Tomcat that's running. That's who is answering our questions. And I can also look at 8,000. And that's the AI advisor. That is the engine that runs AI. All right, so you see that's inside. That's what people have outside. And what's inside is for developers and friends. And what's outside is for people who are really using it. So eventually they will at least have support from me because it's just too much setup. But I also don't want to give away the keys. So the version that I will give to the people, it will not have the keys. But it's a generic architecture. So if you're interested in, I want to run all the software that does pretty much what is standard today, then I can give you that machine for free, and it will run for you for a certain amount of time, and no support required. And there is another application that I need to show you. So you run the terminal emulator here, and there is something you want to run on startup. So it's too much, you don't need all of that, but it's quicker to just start everything. So that's the internal engine that does the processing. This is where you collect the documents here and collect them from different directories, run them. That's where you experiment with AI. And that's what I'm offering you. But of course, those people who really want, then they want to familiar. Okay, to get familiar with that kind of architecture, well, here it is, and you will probably do some kind of processing, and that's why it might be interesting to you. Of course, there is even a manual. Of course, if it's not interesting to you, then you don't have to ask. But if it is interesting, I find that every new project starts with a copy of that. And then you begin to improve it and modify it for your own purposes. It's a different set of documents and different approaches. But that's what I find, that it is pretty much generic architecture. To get that, you will need to email. Just email me. And I don't promise the immediate response because I still need to package it. That what you're looking at is a developer version. And I promise not to give you the developer version, but everything will be running in this version. So if you just email, then eventually in a few days you'll get it. Okay, now with that I can stop sharing again, and again stop talking, and allow you to. Okay, I see there's Jason who wants to talk, right? Well, anybody can talk. If you want to talk, you can. If you want to share screen and show us something that you're working on, or maybe I'll put it here. If not, then our common folder is right here. I'm sharing it again here, and that is, let's find it right here. That's our advanced webinars. Out of curiosity, when did we start? That's December 29, where we are doing it at the end of the year. And the first one was it 22? I cannot believe it. And now that's the end of 23. So we are more than 1 year. Okay? So all you need is this link. I'm giving you that link on chat. So if you need anything like that, that is it for you. Okay, so thank you very much, everybody. I know you're listening attentively and looking. Okay. Olga had dental work, yes. Thank you very much for your encouragement, guys. Okay, and we'll continue next week and in fact next year. So I'm wishing you a great next year full of success in every area. And now saying goodbye.